There are 4 factoring techniques that you should review for this. The first one is GCF factoring. That is when you divide out the greatest common factor. Second is x squared plus bx plus c. That's, I call it unfoiling sometimes. Then number 3, unfoiling when you have a number out front. And then the last one that people sometimes forget is difference of squares. So let's go through and talk about each one of these. Okay, this first one, you always try GCF first. Right here you have 3 terms. And you try to look for what's in common. What can be divided out of each one? Well, each one is divisible by 9. And then let's look at the letters. We've got m to the 4th, m squared, m to the 3rd. What's in common? Well, m squared. There's at least an in all 3 terms. Then look at our m's. N cubed, n to the 4th. Well, n cubed is in each one. And then p squared, p to the 4th p. Oh, that p limits us there. So there's at least a p in each one. So that's what I'm going to pull out to factor out of each of these 3 terms. So then you put your leftovers in parentheses. So let's see. If we factor out, if we divide out 9m squared n to the 3rd p out of this term, what will be left over? Well, we divided out the 9, so that's gone. We divided out m squared, mm. So if we take 2 of those m's out of there, we're going to have 2 left over. And then n to the 3rd, okay, we divided out n to the 3rd, so that's gone. And we divided out 1 of the p's, so there's still a p left there. Okay, plus, next term. If I divide a 9 out of 18, make sure you don't subtract here. You're dividing a 9 out, so that leaves you with 2. The m squared gets divided out. The n to the 3rd gets divided out. Now the p's, 1 of the p's gets divided out. So that means that there are p to the 3rd left, p. Minus 3mn. You want to check now that there's nothing in common here that could still be factored out. Also, another way to check is to distribute this. If you distribute this, you'll get 9m to the 4th, n to the 3rd, p squared, which is that, plus 18m squared, n to the 3rd, p to the 4th, which is that, minus 27m to the 3rd, n to the 4th, p, which is this. So that's our answer. That's greatest common factor, GCF. That's what you want to check for on all of them. So let's check this one. The first thing I want to check is GCF. Is there anything in common between these? Yep. 3y squared is in common. Put your leftovers in parentheses. So if I divide out a 3y squared out of here, everything gets out of there except 1 of the y's. Plus, now 3y squared, I divided everything out of here, so what I do is put a 1. So this is the answer. Now again, to double check that, distribute it. 3y to the 3rd plus 3y squared. Yep. Factoring is just unmultiplying. So you can always multiply to check. Okay, down here, let's see. The first thing I would try is GCF. Is there anything in common between these 2? No. Okay, then I'd try unfoiling. No. So you might be tempted to say this one doesn't factor, but remember to check for difference of squares. Is this a perfect square? Yes, it is. 3x when squared becomes 9x squared, and this one, 8 squared is 64. So the difference of squares rule tells you that this will be 3x plus 8 times 3x minus 8. And again, you could check that by multiplying it out. That's difference of squares. Okay. Number 13. This is unfoiling. We want to find 2 numbers that multiply together to be positive 8 and add together to be positive 9. So I take that 8 and I start listing its factors. 1 and 8, 2 and 4. Do any of those add up to be 9? Yep, 1 and 8 do. So my answer is x plus 1 times x plus 8. Again, I can check that by just foiling it out. X squared plus 8x, that's a plus sign, plus 1x plus 8. And when I add like terms, I get x squared plus 9x plus 8, which is what I started with. Again, we're just unmultiplying when we factor. Right, same thing for number 14. I want two numbers that multiply to be positive 10 and add to be negative 7. If they multiply to be positive 10, I know I either have two positive numbers or two negative numbers. Since they added up to be a negative number, I'm going to assume that I have two negative numbers here. So x minus 2 times x minus 5. Number 15 is the hardest for me because of this number out front here. The way I go about these is by guessing and checking. There's another method that you can look back in your notes if you like that way better. I know that when I multiply these first three numbers, I'm going to get 3x squared. So I need to know what two terms multiplied together would make 3x squared. Now the only thing we can have here is a 3x and an x. And then to get the last number, I know that I need this number times this number would be a positive 3. So I could have a 1 and a 3 or a negative 1 and a negative 3. Since this number is negative, I know that there's got to be some negatives in here. So this has to be either negative 1, negative 3, or the order could be switched around. I could have 3x minus 3 times x minus 1. So now I'm just going to check. I'm going to FOIL this out and see which one gives me 3x squared minus 10x plus 3. I'll do the same here. So let's see, this one would be 3x squared minus 6x plus 3. This one will be 3x squared minus 9x, that's minus 10x plus 3, which is this one. So this is the one I want right here. So this is my answer. 3x minus 1 times x minus 3. This is a tricky problem to me. All right, solve by factoring. So I'm going to factor this. Let's see, I want two numbers that multiply together to be positive 12. Negative 3 and negative 4 multiply to be positive 12 and add to be negative 7. So that's what I want. But now I want to solve this. It tells me to solve. So I can use the zero product rule. I know that I have this times this is equal to 0. To get something to equal 0, either this piece is going to have to equal 0 or this piece is going to have to equal 0. What would x have to be to make this piece be 0? And what would x have to be to make this piece be 0? And there are my two answers.